Okay, welcome back to Mr. Hassan's Maths channel. I'm now going through paper S1, Statistics 1 from October 2019. This is an international A-level Edexcel from Pearson's, and I'm going to start off with question number 1 here. Now, question 1 is about correlation and regression and coding of data as well. It says Jeremiah is investigating the relationship between the annual heating bill H dollars and the total floor area F square meters of buildings. A random sample of 8 buildings is taken and the data for each building are coded using X equals F minus 3,500 over 80 and Y equals H minus 4,500 over 80. The results for the coded data are summarized below. Okay, so basically, this guy's going around and he wants to see if there's a relationship between the floor area and the heating bill for these buildings. He's taken a sample of 8 buildings, and in his data, to make the calculations easier, assuming that that's the reason he's done it, he decided to code the data. So he's taken his floor area and he subtracted from it 3,500 and divided that by 80, and he's called those values X, and the Y values are from the heating bills, which he's taken away 4,500 and divided by 80, and supposedly that's probably made the numbers easy to deal with. So then when he found the sum of those 8 coded values for floor area, he got 5, and he found the sum of those 8 electricity bill annual bills values that are coded, he got 0. When he took the X and Y values, the coded values of X and Y for the coded floor area and the coded bills, and he multiplied them together and then found the sum of those products, he got 1,818. And SXX, this is how this is like the variance of the floor area values, how they're kind of like how spread apart they are. It's a measure of how spread apart they are. That's what SXX is, a measure of the variance of these X values. So they ask us to find SXY. Now, SXY means the covariance of the X and Y values. Right, now, that's something which, in these kind of questions, you've got your formula book, all right? And especially in this topic of correlation regression, something that you'll refer to a lot. Okay, so the formula book, if you go to the formula book, you'll see you've got here for under correlation regression, you'll see you have SXY, SYY, sorry, I've got this written twice, sorry, that should be over here. SXX, SYY, SXY. Right, this is the one that we're looking for, SXY. Okay, so I'm going to just paste that over there so we can see what we're doing. And basically, if you look at this, what we're interested is in that part of the formula. That's what's going to help us in this question, because those are the things that we have the values for. And that will give us like the variance of X with Y. So we can say SXY, if we look at the formula, is going to be given by the product of XY, the sum of the products of X times Y, which is this, which is 1,818, minus the sum of X times the sum of Y, which is going to give you 5 times 0, it's going to be 0 anyway now, divided by N. Now, N is the number of data items, which is 8. There's 8 buildings that we're looking at those values for. So you divide that by 8. Of course, that's just going to become 0 because you're multiplying the top by 0. So you've got 1,818. So there's the answer to part 1. Very simple question there. All right. Now, part B says find the equation of the regression line of H on F in the form H equals A plus BF. So again, from the formula book, I've taken the necessary items. So you've got these kind of items as well. I'm looking at the least squares regression line of Y on X is Y equals A plus BX, where A is Y bar minus B times X bar. Okay, so that means if you want to find the line of best fit, the least squares regression line of Y and X is the line of best fit that passes through those points when you plot them in a graph. That's what the least squares regression line is. It's an equation of the line of best fit. And it's given by Y equals A plus BX. Y is the variable on the Y-axis and X on the, of course, the X-axis. And A is like the y-intercept, and B is like the gradient of the line. You can see it looks like y equals mx plus c. B is the gradient, A is like the y-intercept. And the value of A is found by the mean of y minus b times the mean of x. And the value of B is found, which is the gradient, sxy over sxx. That's what it means. So let's go back to the actual question. All right, so here we have the information that we need right here. Okay, so now, we're trying to find the regression line of H on F. H on F. Okay, in the form H equals A plus BF. But what I'm going to do first, because we have all the values in terms of X and Y, we want to find in this form, H plus A plus BF. Okay, what I'm going to do is, I'm going to find things in terms of X instead. All right, so I'm going to find the regression line of Y on X. That's what I'm going to do first, and then find H on F. So Y on X. Okay, so first of all, we know that Y equals A, I'll just call it A1 plus B1X, because this will be different from those A's, that A and B, all right, in the end. So I'll call this A1 and B1. That's what I'll do. Now, we can first find what A is. We can first find what B is. Okay, we can find what B is because we need B to find A. So we know that B is equal to SXY. We can say B1 is equal to SXY over SXX, as they've told us there. So we know SXY is 1,818. And we know SXX is given to us already in the question as 1,754. 1,754. Okay, so let me just work out what that gives us. So we have 1,818 over 1,754. Okay, that gives us 909 over 877. I'll leave it like that for now, and we can do with that later. All right, so that's what B is. B1, I'll say. 909 over 877. And we want to find now what A is. Okay, now A is equal to Y bar minus B times X bar. Now, we know that Y bar and X bar are found. X bar means the average of the X values, which is the sum of X over the number of values. And Y bar is the mean of the Y values, which is the sum of Y over the number of values. So the sum of X, as we got here, is 5. And N is 8, so that's 5 over 8. Okay. And the sum of Y is the sum of Y over the sum of Y, which is 0, over 8, which is 0. Okay, so that we know that the sum of Y is 0. So therefore we can say, therefore A is equal to Y bar, which is 0, minus B, which we found here, which is 909 over 877, sorry. 877 multiplied by 5 over 8. Okay, so we take this value and multiply it by, and I'm going to store this as A. I'll store this as A. That's our value of B, actually. Anyway, I can store it as B. Let me store it as B. That's our value of B. And I'll multiply this by 5 over 8. Okay, and I'll change the sign. All right, and I'm going to store that as our A. Okay, so that's minus 4,545 over 7,016. So negative 5,400 and 4,500, sorry. 4,545. 4545 divided by 7,016. Okay, so there's the value of A. Let me just move this out of the way. I just need this for the next part. So A is equal to minus 4545 over 7,016. So now I have what I need to work out the regression line of Y on X. So Y is equal to A, which is this, negative 4545 divided by 7,016 plus, and B, which is 909 over 877 times x. That's the regression line of y on x. So now I want to find the regression line of h on f. Alright, so what I can do is I can just basically replace the y with what the code is for y in terms of h. So I say h minus 4,500 over 80 minus 4,000 equals, sorry, minus 4,545 over 7,016, okay, plus 909 over 877 times, and then I'm going to use the code for x, which is f minus 3,500 over 80. Okay, now I want to make h the subject of this in the end. We want to have h equals a plus b times f. So to make h the subject, let's multiply everything by 80. Multiply this side by 80 and multiply this side by 80. So all of this side multiplied by 80 will cause this to become h minus 4,500 equals, now the 80 times that will cancel the 80 you'll have here, and let's just work out what this is. This is times 80 gives us minus 45,450 over 877 negative 45,450 over 877, and I'm going to have plus, and then this 80 will cancel with that when I multiply these two, so I'll have 909f over 877, and then I have to multiply with this, with that term. I'll write them separately. The 80s is cancelled, of course, so it's going to be 909 over 877 times 3,500. So I'll have, let's go back to recall. That's going to be my A. No, it's actually my B. So recall B. Yep, that's that. Times 3,500 times negative 3,500. The 80's cancelled out already. Well, that gives me a decimal now. That's going to be minus 3627.708 minus 3627.708. Okay, so now all I have to do is simplify this. I have h equals, so I've got to take this value here, which I'm going to do this, and I've got to add to it the value I got here. Add to it. I'll just do this, which is minus 4,540 over 877, and then I've also got to add 4,500 because that's going to go on this side, and that gives me 820.46. So I've got here 820.468, 820.468, and I've got plus 909 over 877. Let's write that as a decimal. So I'll put recall B. Okay, what's this as a decimal? That's 1.03648, 1.0364, 1.0364, 1.03648. All right, so that is times, this is your times f. Okay, so that is your regression line that we're looking for. So therefore our answer is going to be, let me round it to 3SF. So you have h equals 820 plus 1.04 times f. Those are the values rounded to 3SF. That's the regression line of h on f. Okay, of h on f. And it makes, yeah, we'll talk about its interpretation in a minute, but that's how you deal with this question. So what did we do first? We found the regression line of y on x first, okay, which is this, and then we replaced the y with the coding for y, and the f x with the coding for f, for x, you know, in terms of f, and then we rearranged it to make h the subject. Bit of manipulation here, but you have to be careful with your calculator and your values, but in the end we got there, and there's the answer to this question. Okay, that's part B. Now for part C. Okay, what I will do is I'm gonna save these, or write these in the next page, in more exact value and in this form, because I think we have to use that. It says given an interpretation of 1, the value of B in your regression line. So let's bring over those values. Okay, so we have here the regression line equation. It says we want to give an interpretation of the value of B. So remember, this is H equals A plus B times F. So we can say B is equal to 1.04. And as I mentioned, the B value is like the gradient of the line. So if you were to draw the regression line, or make a sketch of it, something like that over here. If we were to make a sketch of the regression line, it would look something like this. Okay, you'd have your y-axis and then your x-axis. Okay, it's going to go through 0, 820. That's like the y-intercept. So 820 will be here, and the graph will look something. It'll have a positive gradient going something like that. Okay, so that's what the regression line would look like. So B is, you could say, the gradient. It's like the gradient of this line. Okay, so it's like the rate of change. So it's, you could say, for every, now this is like this is your H and this is your F. This is the bill, the heating bill. This is the floor area. So for every 1 unit increase in floor area, so you can say for every 1 meter squared increase. Remember, this is the floor area in meters squared, and this is the annual bill in dollars. So for every 1 meter's increase in floor area, you have to give an interpretation in terms of the context of the question always. For every 1 meter's increase in floor area, the heating bill will increase by, the heating bill increases by $1.04. Okay, because this is like the change in y over the change in x. The change in y over the change in x. That's what it's like. So for every 1 meter squared increase in floor area, the heating bill increases by $1.04. Okay, so that's what the gradient stands for. And part 2 says given a value of A. Now A is 820. We have to give an interpretation of what A is. Now interpretation means you have to give it in context of the question again. So we can see here that when the floor area is 0, okay, when the floor area is 0, which doesn't actually make sense, I'll explain what it means in a minute. When the floor area is 0, the bill is $820. Okay, what does this mean? It means, you can say, it's the fixed charge. The fixed charge. So when you attach, or when you have electricity supplied to your house, okay, you don't just pay how much electricity you use. You pay a fixed charge for having the service, having the cables connected to your house, having the meter there, and for the service of them coming and reading the meter. So you get a fixed charge that you have to pay. Now, even if you don't use any electricity, you have to pay that charge. So that's what this means here. It doesn't really make sense to say when the floor area is 0, the bill is 820. It doesn't really make sense to say that in context of real life, although in the context of this graph, that's what it actually means. But what it means in real life is that the fixed charge is $820. That's how much somebody would have to pay, even if they didn't use any electricity, just for having the electricity connected to their house. That's what that interprets. That's how you can interpret that particular value. So that's part C done. Then it says part D, estimate the annual heating bill for a building with a total floor area of 4,600 square meters. So we can use our equation, which is H equals 820, sorry, plus 1.04. 820 plus 1.04 times F, and we can say when F equals 4,600, then H is going to be 820 plus 1.04 times 4,600. So we're using the regression line to estimate this value. So we'll do 820 plus 1.04 times 4,600, and that gives you 5,604. That's the heating bill in dollars. So there's the answer to part D. That's an estimation of the annual heating bill for a building with a total floor area of 4,600 square meters using the regression line that we had. Okay, so there we have the answer to this question, which is question number 1 from the October 2019 paper, all about regression and correlation and coding of the data as well. Other questions from this particular paper can be found in the playlist that should appear in this area. Other questions from this topic of correlation and regression from S1 in the playlist that should appear, the link for which will appear in this area, and you can subscribe to my channel by clicking on this link in the middle. Please do check out the links at the end of the video, underneath the description of the video. You'll be able to maybe find some links that are useful to yourselves. Thank you for watching, and see you soon.